In this presentation, I'd like to introduce to you our new software, Allplan Bridge. First, I would like to give you an overview of the principles and the concept of the program, and then I'd like to show you some live demo in Allplan Bridge. The key point of the solution is the parametric modeling. Its principles are illustrated in this picture. If you have a cross-section with variable dimensions, you can just define these dimensions as variables and in parallel define a table which describes the variation of these dimensions along the axis. When you then assign this table to the cross-section, the program can automatically read the respective value of the dimension for each station. In this way, the user just needs to define one single cross-section, and the program will automatically calculate all the deriving cross-section variants along the axis. So if you currently wanted to model a bridge like this in Allplan, you would have to define all these particular cross-sections by hand. So you would need to copy, paste them, modify them, and align them along the axis and connect them by splines. And of course, if you had any changes later on, you would need to manually adapt and adjust all those particular cross sections again. With the new solution of Allplan Bridge, you can just go back directly to your table, modify the values, recalculate your project, and the model will respectively be updated automatically. And this principle is not limited to particular cross-section dimensions, but you can use it for any dimension you might have in your cross-section. So for example, a variable web width or a bottom slab thickness, or also a crossfall with a certain inclination which is changing along your axis. So what are the features of this parametric modeling, which I want to explain to you in the following step by step? First, we have the parametric axis definition, which means you define your axis in plan and in profile, which will then be combined to a 3D axis. Then you define your cross sections, which can be of arbitrary geometry, and any variable dimension can be defined by the user. Then you assign your cross section along the axis, which gives you your structural member. If you have any variations, you define them by tables, as shown before, and assign them to the variable in your cross section. You're free to apply any changes to your model at any time, also during your working process on your model, but also at the finished state. No matter if this refers to a change of your axis geometry or your cross-section dimensions or whatever. The model imported in Allplan has full functionality, so you will find it as if you had modeled it directly in Allplan. That means you can use all drawing objects for further modifications or also for adding additional objects like reinforcement, for example. And finally, the model created with Allplan Bridge can be used for both for drafting and static analysis. So before we go through the particular steps of creating a bridge model with Allplan Bridge, I'd like to introduce a bit the user interface. So on the top of the application, we have the title bar. On the left side, you have the quick access toolbar for commonly used functions and tools. Below that, there is the action bar where there are all the functions and tools that are required for setting up your bridge model, like creating axes, defining the cross sections, and so on. On the left side, you have the window of the project navigation. Here you can find the respective menus for the main tasks of creating your project, like defining axes, defining cross sections, defining variations, and setting up your structural members. On the right side, you have the properties window. So whenever you select an object of your bridge model in one of the view windows, the respective properties will be displayed in this window. And you can view them, but you can also change them and edit them. With these tabs, you can toggle between the particular views. In fact, we have one view of the 3D model and one changing view which displays the content of any selected menu item like axes, cross sections, or whatever. And finally, on the bottom of your window, there is the status and logging bar where there are displayed any warnings or errors that might occur during the recalculation of your project in case you've set up something wrongly. And it's also the area where there are displayed the instructions whenever you do some interactive definition in one of the view windows. So now let's start with the procedure of creating a model with Allplan Bridge. The first thing you do is defining your axis. This is done in separate views. So for the plan view, you have all the design elements that are required, like straight lines, arcs, and spirals. In the profile, you're defining your axis by means of polygon points, which you can then round by parabolas. Then you're combining your axis in plan and in profile to a 3D axis. So this is done by assigning the respective heights of the profile along the axis in plan. So the next step would be to set up your cross sections of your bridge. For example, a hollow box cross section for your main girder. The geometry definition of the cross section is completely free, and it is defined by boundary lines which are created at the intersection points of so-called parametric lines. Actually, the parametric lines are hidden here for better viewing. So to explain the parametric behavior of the cross-section, let's assume we have a variable height of the cross-section. We might have as well a variable bottom slab thickness and maybe a constant chamfer. To accomplish this, we assign the bottom edge of the cross section to a parametric line at this position and assign a variable to it. The same applies to the inner edge of the bottom slab. And then when we apply the variation, for example, I change the height of the cross section, you will see that the inner edge of the bottom slab goes with it in accordance. Or if I change the height of the bottom slab thickness, this constant value of the chamfer will go with it in accordance. So let me run this animation once again. And you see it depends on the definition of your cross section, how the particular parts are depending from each other. Now that we have defined our axis and cross section, we can combine them to a structural member. The following animation shows how to do this interactively. So I'm creating a new girder in my structural members menu. I'm picking the cross section that I want to use. I'm selecting the axis where it should be assigned. define the starting position, define the end position, and I can also apply a subdivision for the elements. Now, if I want to introduce a variation in my model, I need to define a table. So this is done in the variations menu. For example, here I'm defining a new table for the variable cross-section height. In the first column, you can see a list of the stations along the axis. The second column gives the respective value of the dimension. And in the third column, you can see the respective interpolation or transition from one point to the other. So for example, you can have a linear or a parabolic interpolation. You can also check your input in the graphical display. So you can see a linear part and then a parabolic increase towards the pier, and then it decreases again, and we have a constant part in midspan, and same for the second pier. And now in the next slide, we'll see when we apply this table to the variable for the height that we have applied in the cross section, how the structural member will change in accordance. So how this assignment is performed in the program is shown in the following animation. So let me just stop here for a moment. So as we have defined our structural member before, there's also a list where we can see all these stations and subdivisions that we have applied. And in the submenu variation, you can see all the variables that we have defined in our cross section. So here you can see the variable for the cross section height, yet the values are all constant. This is the value that we have used when we created our cross section. So, but now in the next step, we're going to the variation menu where we just have defined our table. And now we just drag and drop the table to the respective variable in the cross section. Then we need to update our database in order to recalculate all the new definitions. And after that, you can see that the cross-section values from the assigned table have been taken over in the 3D member. Then we can define further structural members in our model, for example, piers. This is done in a very similar way as we have already seen for the main girder before. So I'm creating a new pier. I'm picking the point where I want to connect it to the member, picking the cross section I want to use, selecting the start position of the pier and the bottom position, and again apply the subdivision, and in this way I can connect my piers to my main girder. So now let's say we have finished the modeling of our bridge, and now some changes occur that I want to introduce in my model. For example, I just have a constant cross-section height, and now I want to apply some variation to it. So I just go back to my table. I edit the values, and then in order to update my model, I need to recalculate, and you see that the changes are taken over immediately. Or maybe some geometry is changing in my cross section. So I just go there, I edit the cross section, I move the parametric line in order to change the geometry. I update my model, and you can see that the changed geometry immediately is taken over. Or another important case, what if the geometry of my axis is changing? So also here, I can just go back to the respective element. For example, I change the radius. I adapt the curvature in this point as well. So now my axis geometry has changed. Again, I just need to recalculate in order to take over the changes. And you can see that due to the parametric definition, the cross sections are reassigned along the new axis geometry. And the piers, depending on the main girder, are following in the same way. So now when we have finished our model in Allplan Bridge, how can I import the data in Allplan? In Allplan 2018, you will have a new role called Bridge Construction. So when you change to that role, you have a task area Allplan Bridge from where you can import the model. You can select on which drawing files the particular object should be set. And then here you can already see the imported model. So the bridge is created as if you had modeled it directly in Allplan. So you have all the 2D elements, you have the splines, the 3D solids, 3D curves. So everything can be selected and modified and used for further definition. You also have the building structure and file structure as you're used to it. And that gives you a full-featured model in Allplan. Another remarkable feature with respect to a holistic solution regarding BIM for bridges is that we have one data model from Allplan Bridge that can be used for drafting in Allplan as well as for static analysis. In regard to that, we have different requirements deriving from the drafting and detailing and on one side and for the static analysis on the other side. So for example, for drafting, we are interested in detailed reinforcement modeling. We want to model tendons. We have clash detection and so on. And on the other side, for the analysis model, we need additional definitions for the calculation, like we need numbers for the beam elements. We need material definitions. And we need structural supports in terms of, let's say, spring elements with stiffnesses and constraints for certain directions. So in that sense, there are different requirements, and we have one model from Allplan Bridge that can be used for both purposes. So finally, here we have an overview of the holistic Allplan solution for information modeling. So here in the center, you have the Allplan application. And as an Allplan user, you already know the connection to BIM Plus. And on the other side to Allplan Share. So what is new in this scene is that we now have Allplan Bridge with all the features that I just presented you before. And Allplan Bridge can save its data to a so-called TCL file, which is a script file that you can open and edit in any text editor and also re-import into the database. And on the other side, you also have the connection to the analysis software. And you can also import an axis from BIM Plus. So you can, for example, add a file to BIM, a land XML file to BIM Plus, then connect your Allplan Bridge project with this BIM Plus project, and then you can access this land XML file and import the axis. And you see the data flow between Allplan Bridge and Allplan goes from Allplan Bridge to Allplan. So it's just one direction. Yeah, so you only can import the data from Allplan Bridge to Allplan and then process it here. Of course, if you have any changes in the model, you're always free to update at any time from Allplan Bridge to Allplan to have the updated model in Allplan as well. So this completes the overview of the Allplan Bridge product. And now I want to show you some more details in the program itself. So I just opened Allplan 2018 and I'm about generating a new project. So now I'm starting from the scratch with a completely new project. You see this name, webinar demo, it's all empty. And now to start with an Allplan Bridge project, I will change to the role Bridge Construction. And here I have a new action bar, Parametric Modeling, with a task area Allplan Bridge. And the first tool is to create a new Allplan Bridge project. And when I click it, Allplan Bridge will open up and the two databases will automatically be linked with each other. So Allplan Bridge opens with a welcome screen where I can directly continue with my last project, or I could also directly load an example from our library. So this is what I would like to do now. So instead of starting from the scratch, I would just load a template where I can show you the principles of the modeling. So I just click the image and the example is loaded. And you can see this 3-span hollow box bridge, which I will use for my demo. So first, let's have a quick look at the GUI. So I already mentioned this in my presentation. So what I haven't shown yet is one important menu, which is the backstage menu. So if you go to this A symbol, you will enter the backstage where you have first information on your version. Here you can create new Allplan Bridge projects. You can open existing projects on your disk and you can load examples from our library. And here is also where you can save or load your data. So next to the backstage menu, we have the quick access toolbar with some tools for saving or loading project data or recalculating a project. Here in the center, we have the project directory. So I mentioned before that Allplan and Allplan Bridge have different databases. And where is the Allplan Bridge data actually stored? So you see here the path of the Allplan projects and the current project which I've created before. And there is created a subfolder called Bridge and another folder with the name of the Allplan project. And in this folder, there is the Allplan Bridge data. And these databases are now automatically linked with each other. So whenever you update the model, Allplan will always know from which Allplan Bridge project the data should be taken. On the right side, you have some functions which I mentioned before for logging in a BIM Plus project and importing an axis from there. Here's another important menu that will help you a lot. It's all about the help in Allplan Bridge. So first is the context help. You can also open this by pressing F1. So it's the context related help whenever you are in a particular menu and you get the respective help for the input. And we have a quick start guide which shows you how to start a project from Allplan, how to start a project from Allplan Bridge. And we have a getting started example maybe just open this. Now it's opening on my second screen. So here we have a step-by-step instruction for how to set up this bridge, which I'm just showing you. Then we have the particular action bars like defining the axis, defining the cross sections, and so on. And here we have the project navigation. You see the four main menus: axis, cross sections, variations, and structural members. And whenever I'm going to some element in my 3D view, you can see that in the property window, the respective data is shown and I can edit it there. And then on the bottom, we have the logging bar where you can see all the information and warnings and error messages that might occur during the calculation of your project. And by the way, all these windows you can freely arrange. So you can make them floating or tapped, or also put them on a second screen. So what you see here are just the default settings. Now when we want to start with a new project, I'll go to the axis menu, and you can see that we don't have a lot of buttons for creating and copying, but this is all context related. So we wanted to avoid to overload the GUI. So you just go with the right mouse button to the context menu to create a new axis. And I'll just open this now. And there are two submenus for the axis in plan and for the profile. To define the axis, you have the respective action bar. So you start with a point in the global related to the global coordinate system, and then you add the particular design elements. So you could add a straight line, you could add an arc, or a spiral by parameter or by length. So this has already been done here. But you still, for example, if you click a point, you can always see the data and modify this afterwards in the property window. The same applies to the profile. So if I double click, you can see it opens in this view, and the profile has been defined by some polygon points, and the one in the center has been rounded by a particular type, rounding type, like intersection of two tangents, and by applying a respective radius. And the combination of the axis in plan and the profile then gives me my axis in 3D. You can see here this red line. Then the next step would be to create my cross sections. So for this, I go to my cross section menu. Again, with the right mouse button, I can generate a new cross section. I would just jump to the existing one. I will also change to the corresponding action bar. So you can see here the task areas for creating parametric lines and points, and for creating boundaries, and some more definitions. So in this view, you can now also see the parametric lines, which I mentioned before in my presentation. We have different possibilities for drawing parametric lines. We can draw a parametric line parallel to an existing one, or we can draw a parametric line between two intersection points of existing lines, or I can also draw a line by a particular angle. And it's also possible to draw parametric points. So the advantage of a parametric line is that I can link an edge of a cross section, like done here for the bottom edge. So when I want to apply a variation, I can address all the points which are situated on this line. So if I would use parametric points, I would need to define this dependency for each point particularly. However, for other cases, like here where there is no variation, I can as well use a parametric point, like here for this bottom position of the cantilever. And then it's maybe in some cases more quick than generating two lines. So as mentioned before, I need to create these parametric lines in a way that it is possible to draw the circumference of my cross section, which we call boundaries. So I will maybe illustrate this in a very simple example. So let's say we have some rectangular cross section and I created those parametric lines. Then I would just go to the tool uh, boundary, create a boundary, and I click on the intersection points of those lines in order to generate such a rectangular cross section. So the same principle you can use for this more complex cross section as you see here. So we created all the intersection points by parametric lines, and then at their intersection points we created an outer boundary and an inner boundary. A boundary actually describes an area, so therefore we also have um, tools for defining combinations of boundaries, like a minus combination. So in that way, I can tell the program that the area described by the inner boundary, which should be a hole, should be subtracted from the outer boundary. So let's see, I can illustrate this here. Right, so here the combination has already been performed in order to accomplish this hollow. So I think you can already imagine that with this concept, you can realize any possible cross-section geometry that you might have. So let me also delete this out here. And the same applies to the variable dimensions. So for example, if I go here to this parametric line, where the boundary of the bottom edge of the cross-section is linked to, and I change now the position of this line, and you can see how the cross-section parametrically moves according to this line. As already shown and explained in the presentation before, this inner edge of the bottom slab is dependent from the bottom parametric line, and therefore it depends from this position. While the chamfer line here is a constant line and depends on the inner edge of the bottom slab and will move in accordance with that line. Or for the inclination of the cross section, so if I select that line here, you see how the cross section parametrically changes when the variable of the inclination varies. Or for example, the web thickness. And to assign variables in the cross section, you go to the submenu of the cross section. You generate a new variable of the type length or angle, depending on what you require. And then you can see here all the variables that you have generated. You just click the line where you want to assign a variable and select it in the property menu from the drop-down menu. Now the next step would be to define the tables. So for this, again, I go via the context menu to the variation menu, and I define a new table. So again, I will jump directly to the table which I already have defined. So this would be the table for the cross-section height, and as explained in my presentation, you have here the stations along your axis, you have the assigned values and interpolation, and you can just work here like in an Excel sheet. You can copy paste, you can actually also directly paste data from an Excel sheet here, and in this way you can define your variations. Then in the next step I can set up my structural member. So this has already been done here in this model. There is a structural member for the main girder. So to create one, again I would go to the context menu, I generate a new girder, and then you see the command line tells me to select the axis. So I would just click the axis and then pick the cross section which I want to assign to this axis, and then I will select the starting station and the end station like you have seen in the presentation. So I will not do this here again as it has already been done before. So I will cancel this action. So delete this again. And in the same way you can proceed with the piers. So you generate the new pier, and then you select the reference point, something I didn't mention. Uh, this is another definition in the cross section where I can define the position where I want to link my pier axis to. So I just select that point, and then again I select the respective cross section that I want to assign to this axis. I define the top position. I can edit the position. I can define the bottom position, make the subdivision, and then in this way the pier is created. And you can see I do not have to do this in one go, so I can do this in several steps. So if I have a changing element length, or also if I want to assign a different cross section at a certain point, this is always possible. So again, I will cancel this action and delete this pier. And now let's have a look at the submenus of the structural member of the main girder. So there is a submenu stationing where you can see the subdivision which we have interactively applied. And of course, you're always free to edit here or insert a station or edit a station. In the next submenu, we have the assignment of the cross sections. So again, you have a list of your station points, and you have the assigned cross section. And again, you're free to edit this here in the list afterwards. And in the third menu, we have the variation. And again, you have the list of your station points. And in the columns, now you see all the variables that you have used in your cross section. So we have used, for example, the variable h section. And here now I can assign the respective table. So of course, also this has already been done here. So maybe I'll just for illustration, I'll take this one out again. So I need to update the database. I will recalculate. You see there is no more variable height in my girder. So I go back to the list of the variation. I pick the table which I have defined. Here. I drag and drop it to the variable in the cross section where I want to assign it. And you see that immediately the values are calculated according to the information of the table. And going back to the 3D model, and after recalculation, you can see that the values are then taken over again. So when you have finished with your model in Allplan Bridge, you want to import it in Allplan. So you just switch back to Allplan, and the two databases are already linked with each other. So I can just use the tool update Allplan Bridge data. Then I can select how the particular objects should be put on the drawing files. So I would just accept the default settings, and it takes some seconds. And then we can see our Allplan Bridge model in Allplan. And you can also see that all the particular objects, cross sections, 2D elements, splines, 3D solids, curves have been generated and are available for further processing. And in the same way, the file set structure and the building structure has been generated and is available. Okay, so finally let's see what happens when we have some changes in Allplan Bridge. So I'll go back to Allplan Bridge, and let's see, for example, what would happen if there is some change in the axis geometry. So we'll go back to the plan of my axis, and I edit the last point, and I change the radius from minus 200 in the other direction, plus 200, and I also change the curvature in this point respectively. Then I need to recalculate my model. You see now everything is adjusted due to the parametric definition. And again, I switch back to Allplan. So here still my previous model. So I just go back to the tool, update Allplan Bridge data. Then again, it would take some time to re-import database and update the model. And you see now the updated model in Allplan. So this finishes my presentation about our new product. I hope you liked it. Thank you for your attention.